For centuries, architecture has been dominated by the straight line and the right angle, the logic of the T-square and the triangle. But look around you. How many right angles do you see in nature? A honeycomb, a snowflake, perhaps, but in a forest, a river delta, or the human body. The world is made of curves, spirals, and complex, flowing forms. What if our buildings could learn from this? What if they could feel less like machines and more like ecosystems? This is the promise and the profound beauty of biomorphic design. It's not just architecture that looks like nature. It's architecture that thinks like nature. It uses the principles of biological forms, their efficiency, their resilience, their inherent beauty to create spaces that are not only structurally brilliant but also feel instinctively right to us. In this video, we'll journey from the organic visions of a century ago to the computational wonders of today, exploring how designers are harnessing the power of life as blueprints to build a more fluid and empathetic world. Let's start by distinguishing it from simple imitation. Biomorphism is different from literal biomimicry, where biomimicry might directly copy a termite mound's ventilation system to cool a building. Biomorphism is more about evoking the feeling and form of nature. It's the difference between a building that has gills and a building that flows like a graceful, undulating wave. The roots of this run deep. The pioneering work of Antoni Gaudi in Barcelona is a masterclass in early biomorphism. He didn't have modern software, he had gravity and chain models. In the Sagrada Familia, columns branch like trees to distribute load efficiently, and ceilings bloom like canopies of stone and light. He understood that nature's structural logic was inherently beautiful. Similarly, Frank Lloyd Wright's Guggenheim Museum in New York rejects the static gallery box in favor of a continuous and folding spiral, a nautilus shell that draws you upward on a journey of discovery. The real explosion of biomorphic design, however, came with the digital revolution. The advent of powerful parametric and algorithmic design software gave architects the tools to work with nature's complexity. Architects like the late, great Zaha Hadid didn't just draw curves. They designed systems. Her buildings, like the Haydar Aliyev Center in Baku, appear as a single, continuous surface, a seamless landscape of flowing space that erases the traditional boundaries between wall, floor, and ceiling. This is liquid architecture made solid. The software allows designers to use algorithms that mimic evolutionary processes or natural growth patterns, generating forms that are optimized for their environment and structure. Much like a bone reinforces itself along lines of stress. A pro tip for identifying high-tech biomorphism is to look for a lack of repetition. No two panels or components are exactly the same, just as no two leaves on a tree are identical. So, why does this matter beyond aesthetics? The impact is profoundly human. This is where biomorphic design connects with the concept of biophilia, our innate human tendency to seek connections with nature. Study after study has shown that exposure to natural forms, patterns, and light reduces stress, improves cognitive function, and enhances creativity. A room with a biomorphic, undulating ceiling and dappled light can subconsciously make us feel as calm and focused as if we're sitting under a forest canopy. The use of fractals, infinitely complex patterns that are self-similar across different scales, found in ferns, clouds, and coastlines is particularly powerful. Our brains are wired to process these natural patterns effortlessly, and their presence in our built environment can have a deeply calming effect. Biomorphism isn't just a style, it's a form of human-centric design that acknowledges our biological needs. Furthermore, this approach often leads to incredible structural innovation. When you design like nature, you build like nature, with maximal strength and minimal material. The Beijing National Stadium, the bird's nest, uses a seemingly random lattice that is, in fact, a highly engineered structure, providing immense strength with a lightweight web of steel. Just like a real bird's nest, this pursuit of efficiency is not just beautiful. It's inherently sustainable, reducing waste and material use. To summarize the key takeaways: 1. Biomorphic design draws on the forms, patterns, and logic of nature, moving beyond the straight line to embrace curves and complexity. 2. It has evolved from the hand-sculpted organicism of Gaudi to the algorithmically generated masterpieces of Zaha Hadid. 3. Its power lies in tapping into our biophilic instincts, creating spaces that are psychologically beneficial and feel inherently right. And 4. This approach often leads to structurally efficient and sustainable solutions, as it mimics nature's genius for doing more with less. Now I want to hear from you. In the comments below, where have you encountered biomorphic design? Did it make you feel a certain way? Perhaps in a building, a piece of furniture, or even a video game environment? Do you find these organic forms inspiring and calming, or disorienting? Your personal experience is the true measure of this design's power. If this look into nature-inspired architecture has sparked your imagination, please give this video a like and subscribe to Smithage for more content that explores the beautiful future of design.